All right, this is video 7.3. We're still doing circular art and spirals. The objective is I can use algebra to determine the central angles and arcs of circles. And I can find the circumference and arc length. Okay, so those are two different things. Remember, you're focusing on U3. All right, let's go flippers. So the first definition tonight is going to be central angle. All right, so a central angle is an angle whose vertex is the center of the circle. So if we look at the circle down here, it's very nice and beautiful. We're going to use blue, okay? We can identify some central angles. So here we have central angle. I'm going to write this angle here. Angle AOD. And I'm going to go over it so you can see it. Here's angle AOD. AOD. All right? And it's the central angle because, again, its vertex is the center of the circle. So let's go with another couple of these. So now I've listed the other three. We have angle COA, we've got angle DOE, and we've also got angle COE. All of those are central angles. Very nice. All right, so now let's look at arc. Okay, we've been using this word a bit already, but I want to clearly define it for you. An arc is going to be measured by the central angle that defines it. Okay, so if I were to just carefully label some central angles here, and let's actually do that. Let's go with green for now, okay? So here is an arc. Right here, this is arc AD, all right? And that actually looks like this. I want to play like, kind of like a hoop, and then AD. You can also have arcs that have three letters. So let's go with arc CED, okay? So that would be arc CED. Either one of these are arcs. Now, because they're named by the central angle that defines them, if I were to say that angle AOD is 40 degrees, that would make arc AD 40 degrees also. So I could say the measure of arc AD is equal to 40 degrees. Okay? Now, there are three types of arcs. Very cool. One of them you're going to recognize since kindergarten, and that's the semicircle arc. So let's go with purple for that. Identify some semicircle arcs. Okay. So the semicircle arc I want to identify first is going to be DAC. Okay, and that's because DC is a diameter. So a semicircle arc is going to be 180 degrees, which makes sense because a semi, half a circle, 180 degrees. And our example clearly here is going to be DC. You can also go with ACE. This time I use three letters. Okay? Now a major arc is going to be different. Major arc is clearly just going to be larger than a semicircle arc, so bigger than 180. So let's see if we can identify one. All right, let's use orange. So we're looking for an arc bigger than a semicircle. So say we were to go with A all the way around to E, well, we got to keep going because that's 180. We could go to D. So we could say that this would be arc, and again, it's bigger than 180, so I'm going to say greater than 180. And our answer could be arc AD. And you want to actually say arc AED, so the reader will actually know which way to go. Let's also set another arc that makes sense for us here. And let's start this time with D. So if we started with D here and we went all the way around, okay, we got to go past C. So we'd go to E. So we could say arc DAE. That'd also be a major arc. Now minor arcs are going to be exactly what you think they are, and they're going to be smaller than semicircle arcs. Doesn't that make sense? It's just so beautiful. Okay, so less than 180. All right, so that would clearly be, if you're looking here, you're going to see this one here, and that's arc DE. Okay, arc DE. Don't need a letter in the middle because we can go right from D to E and we don't cross over any other letters there. All right, so let's talk about arc measure. So arc measure is always in degrees. Always. You always have a degree measure. So hey, if angle DOE is 60 degrees, the arc measure of arc DE would be 60 degrees. Okay? The measure of a major arc is going to be equal to 360 minus the measure of the related minor arc. So it's kind of like the whole pizza versus the major piece leaves the leftover piece, which makes sense to you. The same thing is going to be true for the minor arc, okay? The minor arc is going to be the measure of the single or central angle that defines it. The central angle that defines it. And we just looked at an example of that here when I said to you, angle DOE is going to be equal to the measure of arc DE, which is also 60 degrees. I apologize right now. I know this is a long video, but there's a ton of stuff, and I'm going to speak really, really fast. So here we go. Circumference, young people. You know what circumference is. You've been learning that since you were in probably like, I don't know, 3rd grade. It's the distance around a circle. So hey, see that circle right there? Its radius is 3. So the circumference is pi r, okay? We can plug in what we know. Up with 6 pi algebraically, and we need to change this to add units, so it'll be 6 pi feet. Okay? Arc length is going to be the distance measuring a section around a circle. So if I had a circle, I wanted the arc length of this circle, then what I'm looking at is, again, I'm looking at that arc that we were just talking about here, but now I'm going to give that arc an actual measure. Okay, and the measure is not going to be an angle measure. It's going to be a measurement like this many feet, this many centimeters. And that's what we're going to work on now. The formula for the arc length of a circle is, if we were to give this a and a B, we'd be looking for the length. Okay, so I actually want to write the word L here, so we know this is length. We want the length of arc AB. That's going to be equal to the actual measure of arc AB over 360 times, you're not going to believe it, 2 pi r. And where did that come from? Oh, it came from this, the circumference. That's right. It comes back again. You have to use that circumference there. So you're looking at a ratio. So let's try these. All right, so here's question number 1. And question number 1 says, name the central angles. Okay, so the central angles are going to be angle FOB, angle FOE, angle COB, angle EOC, angle EOD, and there are several more, but those are just a few of them. Let's also try and name some of our major arcs and minor arcs. So let's start with the major arcs. So here I've named 2, and I'm doing this in this way. I'm saying, you know what, I need a major arc, so I'm going to have to go to the circle. I'm looking for the diameter, so I see CF here is the diameter. So I know that those 2 letters can be a part of the major arc, but I need another letter to make it bigger. So I'm going to go from C to F to E. So that's how I got my first one. Then what I want to do is I want to find another one to give you at least 2 examples here. So I'm looking at BE again because BE is the diameter. So I know the first 2 letters could be BE. But then I want it to be bigger than a semicircle. So I'm going to go right to C. And I went actually the wrong way, so I'm going to back up and show you the right way to go. Okay, so if I was to actually start at BE and go around that way, there I go, and then all the way to C. Okay, so this would actually be my major arc. All right, so now let's name some minor arcs, just 2. Let's go for 2 minor arcs. I've named 3. I've named BF, clearly smaller than a semicircle arc. BC, again the same thing, and then ED. All of those are minor arcs. So let's look at question 2. What is the measure of BC? Okay, so we see clearly that the angle here, the central angle, which is BOE, is 32 degrees. So we are looking for the measure now, measures in degrees of arc BC. So we know right away that this also has to be 32. degrees. So here we're clearly at example number 3. And example number 3 says, what is the length of the arc shown in red? Leave it your answer in terms of pi. So here we want to follow the procedure that we just did. We want to say, hey, I want a length. So I know this is going to have to involve some type of circumference. So circumference is 2 pi r. That's just that expression that I need. Now I need to know what is the ratio between the measure of arc xy, because that's what they want. They want this arc here. What is the measure of arc xy? And then what is the total amount of degrees in any circle? Oh, it's 360. Yeah, that's right. So now I'm just going to plug in what I know. Well, I know that this major arc over here is 240. And I know that 360 minus 240 will give me 120. So that means the measure of arc xy has to also be 120. So that means I can plug that in over 360. And then I can multiply that by 2 pi r. And it says to leave it in terms of pi, so let's simplify this. That's to 1/3 times 2 times pi times r, which simplifies to 2/3. We want to plug in what r is, and here we have that it's clearly 15 times pi. So this is going to simplify to 30 over 3 times pi, which simplifies to 10 pi. And again, this is centimeters. We're done. So last but not least, let's look at the question 4. What are the measures of, well, I'd like to know what the measures of arc PR. What's arc PR? What does that measure? Okay, so if you look at it, you should clearly see that the measure is 77 degrees. You couldn't wait any longer. Here it is, your secret hot question. So you're going to look at this beautiful circle and you're going to tell me these 3 things. What are the minor arcs? What are the semicircle arcs? What are the major arcs of E that contain point D? I would like a minimum of 2 to 3 answers for each. Have a great night. U3, don't forget U3. 5 and 5.